Hi, and welcome to this clip going through a long answer intermolecular forces question. It's been taken from the OCR Rings, Polymers and Analysis paper F324 from 2014. So, the question is about these structures. The question gives you the structures at the beginning. So we're just going to have a look at part C. So propanone dissolved in ethanol and methylbenzene dissolved in hexane. I want you to name the strongest type of intermolecular force or bond that's formed between propanone and ethanol and methylbenzene and hexane, and it asks you to explain how the intermolecular bonds you have named are produced. I would suggest maybe the first thing to do is to consider doing each bullet point as a separate section of your answer. So let's do propanone and ethanol, and you can draw them out to illustrate what you're going to do. So you can put the dipoles on, and then you can have a think about what's going to happen in terms of intermolecular forces between them. Now, the reason this question is a little bit more challenging is because it asks you to consider hydrogen bonding, or the intermolecular potential for hydrogen bonding, between ethanol and another molecule that you wouldn't normally associate with hydrogen bonding. So if you put a lone pair on the oxygen of the C double bond-O bond in propanone, a hydrogen bond will form and an attraction will take place between those two molecules. So the next thing to have a look at is the methylbenzene and hexane. So again, you can draw out the two molecules to help you visualize what's going on. So the electron distribution in each molecule is sometimes in balance. So as they don't have any polar bonds, the only intermolecular force you're going to get is London forces. So the imbalance of electron distribution in a molecule can cause what's called an instantaneous dipole to form in that molecule. That can then induce another instantaneous dipole in a neighbouring molecule, so they attract to one another. And in doing so, this explains how the London force arises. Okay, so I hope this short review of this question gives you a few insights into how it might be dealt with if it was to come up in a test. But for now, thanks for listening, and until next time, see you soon.